Okay, this is part 2 of our Intro to Programming in C# in Unity. We're going to be covering some of the techniques that we expect to see you use in your projects, and you will master over the course of the next couple of weeks. Okay, so here we are, part 2. This is going to be kind of a little bit shorter, specifically because we're going to go through, just about oh, half a dozen to a dozen slides, mostly on conditionals and loops. And let's see, whoops, not that transition, this one down here. Okay, so I mentioned before about the if-else, which is the most basic, most flexible conditional in C#. Else is optional. You don't really need to say the else. You can, well, you only need the else if you have an else condition. You can just have an if condition. So if condition 1, then whatever's within the curly braces, within that scope, that is going to run. You can, of course, have an else, and you can even have an else if to create these sort of compound if statements. So in other words, if condition 1, do this, else check this condition, if condition 2, and run this, else do this. And then you can even embed ifs or nest ifs inside of other elses. So in any block of code, like for example this last one here, you can always embed another if condition in here. So have if condition 3. So this one would only get down here if both of these were not met and this one was met. Right? So you can set up these sort of complicated things, like you might say, oh, if you have the key and you are on this location in the game, right? So that might be an if, or you could have it as either an and, or you could say, well, if this, say one thing, else, if something else is met, do something else, and so on. So it's sort of complicated combinations of statements. So if else is your friend, chances are you will definitely be using some of those. Another program flow structure, another piece of structure in your code that comes in really handy, is switch or case statements, switch case statements. It's an alternative to several if statements and kind of can streamline your code quite a bit, rather than having a whole bunch of if this, do this, if this, do that, if this, do that, if this, do that, and so on. You can use this switch case. So what you do is you basically can compare for equality some certain number or some certain variable, and then act accordingly. All right. So for in this example, it switches on num, so it considers num, and it compares it to each one of these cases. Now, if that case is matches, then it runs the code in that particular case. The best form is, of course, to have the case, the code involved in there, and then you have a break after each of the statements. That means, okay, the code that you want to run for this condition is done. Okay. So what happens if you leave out the break? This is, let's see, if the case has no body, execution falls through the next case. Otherwise, there is a compiler error. Right? So in this case, you could say case 3 or case 4. These should happen. But if there was code in there, then it would result in an error. Right? You have to have blank cases. So you can say, oh, 3 or 4, then this would happen. So we could let's demonstrate that one real quick to make sure that is doing the right thing. So we'll go over to Intro Project here, and we have our game manager. We'll open that up, and let's see. So we could say, we'll come down here and say switch, and we'll switch on number of lives. Okay. And we'll say case 3, case 4, and whoops, I should have this here. And it's always good to have a default as well. I always like to put the default in first, just in case, and say, so here we could say print you have 3 or 4 lives. And here it's saying control cannot fall through one case label to another. Okay, let's say this. There. Now it's okay, right? You have to have a break after something that contains code. This is okay as long as it doesn't contain any code. Let's see, print. You have 2 lives. Right? Notice I get this error here. Control cannot fall through from one case to another. But let's see get away with it in this case here. In this case, pardon the pun. So we'll come in here and hit play. It says you died. Okay, that's not good. So let's clear the console, go to our game manager, and set this to 4. And run our code again. You have 3 or 4 lives. Let's try that again. 3. You have 3 or 4 lives. Okay, so it did work out to be what we thought, what we predicted. All right. So this is that one special instance in which case you don't need a break statement because you can have multiple cases that are met and then that executes. But you can't have a piece of code without a break in there. All right. So loops. Loops are going to be your friends. Loops are when you need to execute a chunk of code a number of times or some repeated until some some condition is met. Okay, execute the body of the loop repeatedly so long as the condition contained in the while, in the parentheses of the while, is true. So while loops check the condition first, do while loops check the condition last. Okay, so it's really just a matter of do you want to check on the way in or do you want to check on the way out? If you know you want your loop to at least run once, it makes sense to try things to do a do while. Right? It's a little bit more efficient because you avoid this check at the beginning, so you know your code needs to run. All right? So in this case, we have both versions here. We say bool is alive equals true, int health equals 10. There should be a semicolon here. Here's a bug. Okay, and this will say while is alive. It'll iterate through this loop, decrementing health as it goes until is alive is 0 or false. Sorry. While is alive is true, keep running this. So until this code here runs and sets is alive to false, it's going to run over and over and over again. So it's going to tell you how much health you have until health is less than or equal to 0. And then it runs that. Now in this case, this is sort of the resurrection loop. This is the rundown loop, and this is the resurrection loop. Do if health is less than or equal to 0. So health is 0. You are a zombie. Okay, so assume you're doing your death save here, right? You're iterating back up again. Otherwise, so it doesn't run these else statements here because this would be met the first time in. Then it would add 1 to health, run the loop again because is alive is, let's see, is alive true? Let's see, did is alive get set true? If health is 0, you are a zombie. Wow, it would have just fallen through here, right? Because is alive is false, just fall right through and end. So what should have happened is we should have turned is alive to true just in case so that we would have then recovered health. So there's a bug here. All right. So it would run through, say is alive. Oh no, wait, let's see. What should have happened is this if health plus plus happened up here, we would have then wound up setting is alive to true once you hit 10. This is some buggy code. I can't believe I didn't fix this before. All right, so it's basic do and do while loop. Okay. Now say you want to run a loop a certain number of times. and you know the number of times you want, or you know a specific condition you want, and you want to have something that sets up that condition, then checks the condition, and then modifies the condition potentially. So this is probably a more common loop than even the while loop. So usually used for repeating a specific number of times, very similar to a while, but is more self-contained. The for piece of it says for, and then you have a starting condition, so you can say int I equals 0. So this will start out at the beginning. Before the loop runs, it runs this, int I equals 0, so it sets I to 0. And then this is sort of the while condition here. It's going to do this while I is less than 10. So it's kind of a combined a while loop in here. So it sets a condition, checks that condition, and then runs this code. So it'll run through once, and then it'll increment. So let's actually do this. Let's show this running here. Okay, we're back to our starting project. And the next thing is we'll do here, we'll do our for loop. For int I equals 0. I is our iterator here. I less than 10. I plus plus. Right, so we're going to increment I each time the loop runs. Print, and we will just say print I is now, and we will put I there. Okay, so this is about as simple loop as you can get. Come over here, look at our console window. Okay, so it starts off at 0, gets to 9, and stops. Right? Because our code says I is less than 10. Right? So the moment I hits 10, this condition is no longer met, and it pops out so it doesn't run that next loop. If you wanted to run, this is running exactly 10 times, starting at 0. Right? The first iteration is 0. So this piece here is run after each iteration of the loop. Okay, so that's how the for works there. Okay. Jump back over to our presentation here. For loops, very, very, very simple. Now, for each, very similar to the for loop, but it's going to iterate through members of a collection. Now, we haven't covered collections yet. Collections are groups of variables, or it's not a group of variables, it's a group of similar kind of slots for variables. You can be an array, you can be a string. Right? So if you have an array which is, say, 10 strings, or a list that is a bunch of strings, and you want to operate on all of the things in that string, or all of the things in that list, you would use for each. So like, for example, here, I might have a list of strings that was player names. So I'd have a certain number of player names in here, Bob, Fred, Janice, and so on. And then I would say, okay, for each string p name in player names, do this in here, right? So if that list had gotten those things added to it, maybe this was a print statement. It would run through once for each element of this list. Okay, that'll come in handy as well. So what if you want to interrupt a loop? You want to stop a loop in the middle. For some reason you hit some magic value, or you did some calculation and you know you've reached some limiting factor. For that we have two things. We have break and continue. So what break does, break dumps execution out to the end of the loop. So if we want to stop the loop, we can just use break. So for example, this might be checking the elements of this list, foo list, and we're going to look at each one of them. So we're going to say, okay, for each list of each in the list of our for each int in our list, we're going to run the body of this loop. So it's going to say, okay, for each one, check is foo equal to 12. The moment it finds any of them equal to 12, it'll print found 12 and then break out of the loop. Okay. So it's a handy way if you're like trying to find, okay, are any of the things you encountered this type of object? You know, Is anyone in the party a zombie? If so, break the moment you find the one that's equal to a zombie, right? Without having to check everybody in the party. If you found one, you might as well move on. Now, continue causes us to stop the current iteration, but continues on with the next. So continue will say, okay, don't do anything else that follows, but just use the next iteration of the loop, right? So stop processing. Like say you only wanted to process the odd numbers in here for each int foo in our foo list again, which might be 1, 2, 3, 4, 5, and so on. We would check if foo mod 2, so there's no remainder when divided by 2. If there's no remainder, continue, which means come back up here again. If there is a remainder, so this isn't set, this happens. Notice there's no else, but this happens, and then the next iteration of the loop. Right? So the continue causes it to stop the processing, but continue the next iteration. The break says, okay, stop processing and don't continue. Right? So it completes execution of the loop. It stops where it is and completes execution of the loop. The continue stops the execution of the loop here, or this particular iteration, but continues on with the next iteration. All right. So that was a quick introduction to some of the most basic structural elements that you can have in your programs. It should be very, very similar to things you've encountered in other programming languages. Just some of the syntax might be a little bit different. You may or may not have encountered for each before. Those will demonstrate a lot more as we get into collections, which will be one of the subsequent lectures here. So just wanted to have this, post this as a reference to some of the basic code. Now with all of these techniques is really just about all of the code you need, all of the basic syntax and structure that you'd need to do certainly the first homework. I'm going to follow up with a couple of different techniques or demonstrations of things like audio sources and some of the other Unity game objects and how we can use these structures with those as separate tutorials. So until next time, hopefully you're able to kind of follow along. Go ahead, try this, use it in the Unity editor, similar to how I've been doing things. You can just go ahead and use this simplest thing to do is sometimes just use that start, just act as if that's your main function for now. We can do that, right? That's a convenient way to do that, right? So imagine here, I can do this example. If I equals 5, break. I would say, okay, what's going to happen? You'll see that now, I should really never be editing stuff. You can edit scripts. Scripts will still get saved, but modifications made in the Unity editor will not happen. So you can see now, 0, 1, 2, 3, 4, 5, it stopped execution of that loop at 5, right? Now, if I had said continue instead of break, there, right? But let's put the print statement. Let's be clever here. Put the print statement here. So now we'll see it iterate through the loop, but it will not print when 5 is encountered. So let's clear that out and run. And you'll notice I is now 0, 1, 2, 3, 4, nothing for 5, 6, 7, 8, 9. Right? Because that middle condition, 5, said, okay, continue. Go to the next one. Okay? Now let's do a quick example of our do while. So say do, maybe I'll start with while, and we said is alive. And just for the sake of argument, I'm going to establish a little bit more scope here. So I'm going to, I liked having this structure here. Let's put that there. So that if I declare any variables here, they should be limited to the scope in here. So I can have some local variables. I'll say bool is alive. equals true. Okay. Now I'd have to be careful. If I don't modify is alive, this is an infinite loop here, and it will just loop forever. So I'm going to do this right away. But I need some condition to say if is alive equals false. So if, and I will decrement number of lives. Minus minus number of lives is less than or equal to 0. I'm going to stop the loop there, right? So let's do this. Print number, I'll say lives left is plus number of lives. And just to separate this, it's just a technique. Just to do that. All right. Come back over here, clear this out, and hopefully don't have an infinite loop. All right, so you see here, there's the new section. Number of lives left, 3, 2, 1, and then it stops because I died, because that was 0 there. Okay, and I do want to be careful. Now, I don't know if I explicitly said this before, but if I don't have braces like this, an if will only execute the next single line. So like in this case, the if I equals 5, continue. This is the only code that will happen as part of this if, unless I have the braces around. Now, anything that's within those braces is executed, right? So it's good form, even if you have just a single line. Often you want to put some braces around there just so you have enough scope to make sure that you don't wind up missing any code there. So that's a good one to have. And I think that should do it as far as some of our demonstrations here of a while loop. I could do a do. Let me do the do loop now. Do, so say I know that we've come in here and we would say while not is alive. That would be a better version of that. Now I do need a semicolon at the end there. So I'm going to do something until I return back alive. So I'm going to say if number of lives is greater than, say, I'm going to do that so that what's going to happen is it's going to say, okay, I've got to have at least 2 lives in order to be is alive. For some reason, that's what I decided to do. We'll say is alive equals true. Okay. And we'll say right here, if is alive, or if not is alive, we'll say print not alive yet, but lives equals plus number of lives. Okay. And down at the bottom we'll say print we're alive. Okay. Clear that out. All right. So what happened here is we decremented the number of lives, and we got out of that loop by being dead. And then we went into this, and it said, oh, not alive yet, but lives equals 1. Not alive yet, but lives equals 2. And then we were alive, because in our loop, we set alive to true the moment this increased past 2. Okay. Now, let me show you one last bonus thing, and we'll get a little bit more into this next time or in a future installment, but let's look at the debugger really, really quick. Now, there's a built-in debugger in Visual Studio, and that allows you to kind of look at the execution of code as it happens. One of the simplest things to do is you come over here, you point and click here, you set a breakpoint. Okay, I will say attach to Unity. That means it's going to attach itself to the Unity process here, and the moment I press play on Unity, something wonderful will happen. I'll hit play in Unity, and it will freeze. And it hits this point of execution. The little yellow line means, yes, that is where or what it is about to execute. And in here, I can see what all of my variables are in here. So number of lives equals 0. That didn't happen because the Unity editor set it to 3. And now I can step by step, you see up here, show next statement, step into, step over, step out. So I'm going to do this. I'm going to step into, and you'll see it didn't execute this. It jumped right over that into this code because number of lives is 3. And we'll step again. Okay, so it's going to run that. And that happened over here. I should have cleared this beforehand. So now we're going to go into here. Now, switch number of lives. You'll see this is the one that happened because I had 3 lives, so this is what's printing. I could follow my execution straight on through here. Break. Now you'll see it jump through each iteration of this loop. Skipped over that because I is not 5 yet. Printed. Skipped it again. Now if you look here, we can see what I is equal to. And 3, 4. Now this is the one. Ready? Here's 5. I is 5, so this should happen. Let's step in. Okay, the continue happens. Now you'll see it didn't do this print. Now if we wanted to, we could set another breakpoint. I'm going to set another breakpoint here. I just left click right there. Say continue. Finish up that loop. Get to that print. And I'll step over that. And I can go through the iterations in here. Stepping through to see how the code is executing. So this is a really, really handy way to kind of go through the code and see what's happening. So this is interactive debugging that Visual Studio gives us. So this will be really, really handy for those of you, for everybody in the class, not just those of you who are interested, for everybody to debug their code and kind of figure out what's going on. All right, so by default, hopefully you have installed the appropriate debugging. It should be installed with Visual Studio when you installed it. If not, let me know and I can kind of walk you through and help get you installed on there. So, all right, we'll call it a day there. Any questions, please ask on Discord, direct message me, or ask as part of the group. Thanks. Good night or good day.